Hi guys, welcome to the mathematics platform. Today we are going to talk about linear motion, and the specific objectives for this topic are to define displacement, speed, velocity and acceleration, distinguish between distance and displacement, speed and velocity, determine the velocity and acceleration, plot and draw graphs of linear motion, that is distance and velocity time graphs, interpret graphs of linear motion, define relative speed, solve the problem involving relative speed. As a part of introduction, we need to understand what linear motion is. When we talk about linear motion, is a one-dimensional motion along a straight line. And we have two types of linear motions. A motion with constant velocity or zero acceleration. That is, when a body or a car is moving at 80 kilometers per hour without increasing or reducing the speed, then we say it is not accelerating. Therefore, it has zero acceleration. And also, another type of linear motion is a motion with variable velocity, or what we call non-zero acceleration, meaning that if a car is moving at 80 kilometers per hour, after a while it increases to 120 kilometers per hour, and then reduces to 80, reduces to 40 kilometers per hour, then that car is moving at a non-variable velocity or non-zero acceleration. Let's talk about distance. When we talk about distance, it's the length of a path joining 2 points. Length of a path joining 2 points is what we call a distance. Displacement is the distance in a specified direction. And therefore, you realize there is a difference between distance and displacement. Because distance is just a length joining 2 points, and displacement is that distance in a specified direction. Therefore, displacement has both direction and magnitude, or what we call size. But distance has only magnitude with no direction. Hence, displacement is a vector quantity and distance is a scalar quantity. Let's talk about speed. Speed is the distance traveled per unit time. We usually say speed equals to distance all over time taken. When we talk about average speed, if a body was moving at some different speeds, 80 goes to 120, goes back to 40 and all that, it moves with variable speed or velocity, then we say for us to get average speed for the whole journey, we find the total distance the vehicle or the car has traveled divided by the total time the car has taken to reach the destination. When we talk about velocity, is the speed in a given direction. Speed in a given direction. So velocity is a speed in a given direction. And therefore, average velocity, if it started with a certain speed or a certain velocity and increased with time or accelerated, then we say to find the average velocity for the journey, it is the initial velocity plus the final velocity divided by 2. And then when we talk about acceleration, is the rate of change of velocity. The rate of change of velocity. Acceleration is equal to change in velocity over time taken, meaning we can also say it is the final velocity minus initial velocity over the time taken. That is what we call acceleration. Now, this is a diagram that is demonstrating the difference between distance and distance and displacement. This is distance because it has magnitude, because you can measure the length from here to here, but it has no specified direction. You see here it's moving upwards, then it moves downwards, then it moves upwards, downwards. It has no specified direction. But displacement, there is a specified direction from A to B in a straight line. That is the difference between distance and displacement. Displacement has both length, which you can measure, which is the magnitude, and it also has direction from A to B. And distance has only magnitude. You can only measure the length, but you cannot tell the direction. Let's do some examples on this. Example 1 is a man walks for 40 minutes at 60 kilometers per hour, then travels for 2 hours in a minibus at 80 kilometers per hour. Finally, he travels by bus for 1 hour at 6 kilometers per hour. Find his speed for the whole journey. Here you are required to find the speed for the whole journey. You see, the traveling was with different speeds and different times. And therefore, to find the average speed, we find the total distance covered over the total time taken. For us to get the total distance covered, we know that speed is equal to distance over time taken, meaning that distance is equal to speed times time. So we find the first part of the journey, we find the distance he covered. The distance this man covered for the first part of the journey, it is 60 kilometers per hour times 40 divided by 60 to change it into hours. That is 40 over 60 times 60, we get the distance he covered in the first part of the journey. Then plus the second part of the journey, it took 2 hours in a minibus at 80 kilometers per hour. So it is 80 kilometers per hour times 2 to get the distance covered in the second part of the journey. And finally, it travels by bus at 60 kilometers per hour for 1 hour. So we find the distance, which is 60 times the 1 hour. To get the total distance, we add all these. This is 40 plus 160 plus 60, you get 260 kilometers. That is the total distance the man covered for the whole journey. Then we find the total time he took for the whole journey. We have the first part in hours, 40 all over 60, which you get 4 over 6 or 2 over 3, plus 2 hours the second part and 1 hour the last part. This gives you 3 and 2/3 hours. Now we find the average speed, which is 260 kilometers divided by 3.5 hours. This will give you 70.9 kilometers per hour. Example 2. A car moving in a given direction under constant acceleration. If its velocity at a certain time is 75 kilometers per hour and 10 seconds later it is 90 kilometers per hour, find its acceleration. Remember here in this question, you've been dealing with kilometers per hour and you have 10 seconds. So the unit is very essential. And you also have here 90 kilometers per hour. But you are also talking about seconds here. Seconds only goes with meters per second. And therefore, we have to think on how to change it. On how to change this. So acceleration is equal to change in velocity of the time taken. So the change in velocity will be 90 minus the initial velocity, which is 75, divided by the time taken. Time taken, we have to change now the kilometers per hour. We times 1,000 to change to meters. We also change the hours into the seconds into hours. 10 seconds into hours, we multiply 60 times 60. That is 60 minutes, and 60 minutes that will make 3,600. From seconds to minutes, then to hours. It gives you 3,600. So we multiply this, we will finally get our acceleration as 5 over 12 meters per second square. Because of these seconds, if it were in hours, we could have not changed anything. We could have divided direct. But now we ought to have changed to meters per second. Example 3. A car moving with a velocity of 50 kilometers per hour, then the brakes are applied so that it stops after 20 seconds. Find the acceleration. The car is moving with a velocity of 50 kilometers per hour. Then if you apply brakes, it stops. So the final velocity here, it is 0 kilometers per hour. It is 0 kilometers because it goes to stop to 0. It breaks after 20 seconds. Remember here we have seconds and this is kilometers per hour. So we need to change this to meters per second. So we multiply that by the 1000, we divide by that 600, we shall have got the meters per second. So here we have said that this is 0, the final velocity, minus 50 all over 20 times 60 to change to seconds to change to meters. So we will have our final answer as negative 25 all over 36 meters per second because it was decelerating, it stopped, it reduced the speed, the velocity. So the negative acceleration is always referred to as deceleration or retardation. Let's talk about distance time graph. When distance is plotted against time, a distance time graph is obtained. This is the distance. You plot it against the time. We will have a graph like this one, which we call a distance time graph. Here we have a steady speed. The speed here is constant, steady. Steady. It is increasing steadily. And then here we have a constant speed. It went with a constant speed at this point. And then it started reducing the speed, returning to the start, the 0. Velocity time graph. When a velocity time graph is plotted against time, that is when a velocity is plotted against time, a velocity time graph is obtained. This is how a velocity time graph looks like, whereby this body is running, or the car is accelerating at this point, then it goes with constant velocity at this point, then it starts what we call retardation here. It reduces the velocity to 0. So you realize that speed is equals to distance over time taken, and therefore distance equals to speed times time. So the graph is made up of small rectangles. If you divide this one and this one, we shall have a big rectangle here. And then if you divide this triangle, you can have small rectangles. The small rectangles whose area, if you find an area now, because you have the what? At this point you have the time times, at this point you have the velocity. Velocity times the time gives you distance. And therefore, that is the speed times the time gives you distance. And therefore, the product of these speeds and time, which gives you distance. Hence the area under the whole, the area under curve. The area under curve gives you the total distance. So if we wanted the total distance for this, we only find the area under this curve. You can divide this into 1, 2. That means you'll have 1, 2, 3 figures, a triangle, a rectangle, a triangle. Or you can have it as 1, which is a what? A trapezium. And find the area of the trapezium, or find the area of this triangle, plus the area of this rectangle, plus the area of this, to give you total distance. That is an example of velocity time car journey. Work out the total distance traveled by the car and work out the maximum acceleration of the car during the 50 seconds. Now, you realize that this is a body that is the car is accelerating here, then it goes with constant velocity here, it accelerates again, and then it starts decelerating to 0. So that means we have two parts of the journey where the car accelerated, this part and this part. And this answers our question here, the last part of the question, that we find the maximum acceleration of the car during the 50 seconds. So what we'll do for us to answer that question, we'll find the acceleration at this part where it accelerated and this part where it accelerated. Then we compare the two acceleration to find the maximum acceleration. Then to find the total distance, as we have learned from above, is that we find the area of the figure. So we shall divide this figure into parts as follows. Part A, which is a triangle, then we shall have part B, a rectangle, part C a trapezium, and part D a triangle. So then from there we find the area of all the parts, and then we add up all the area to find the total distance. So the first area, it is a half times area of a triangle is half base times height. So it is half times the base, which is 10, times our height here is 15, which gives you 75 meters. Then the second part is a rectangle, which is length times the width, and the width here is 10 times our length is 15, which gives you 150 meters. Then part C, it's a trapezium, which is a half into brackets a plus b times the height. Our height here becomes this one, that is 30 minus 20, which is 10, and our a, we can take this to be our a, which is 15, and our b, which is 25 here. So we shall have a half into a, which is 15, plus b, which is 25, then times 10, then times a half, and this gives you 200 meters. Then part D, we shall have a triangle, which is half the base 10 times the height. The base is 50 minus 30, which gives you 20. So we shall have a half times 20 times 25, which is our height. Then we get 250 meters. So therefore, the total distance traveled, you add all this. 75 plus 150 plus 200 plus 250, which gives you 675 meters. That's the total distance that was traveled for the whole journey. For us to answer the question of the maximum acceleration, I've said that we find the acceleration is in the two parts where the body accelerated, this part and this part. Then we compare the two to find the maximum. The acceleration at this part, the first part of the journey, is the final velocity, which is 15, minus the initial velocity, which is 0, divided by the time taken, which is 10. This gives you 1.5 meters per second square. Then the other part where it accelerated is here, whereby now this becomes the initial velocity, that's the 15 meters per second, and the final velocity becomes 25 meters per second. So with 25 meters per second minus 15 meters per second, divided by the time taken from here to here, it is 30 minus 20, which is 10. So when we find that, we find the acceleration as 1 meters per second square. And therefore, the maximum speed acceleration was at the first part of the journey. That is where the car accelerated most. So the acceleration was, maximum acceleration is 1.5 meters per second square. Now, let's talk about relative speed. When we talk about relative speed, this is the speed of a moving body with respect to another. For you to talk about relative speed, you must compare two vehicles or two cars. They must either be moving in the same direction or in different direction for you to talk about relative, because you are comparing one body with another. That's the speed of a moving body with respect to another one. So when bodies are moving in the same direction, for us to find the relative speed, if they are going the same direction, let's say they are moving from Nyeri to Nairobi, both are going the same direction. For us to find the relative speed, because one might be running faster than the other, at a higher speed than the other, so what we do, we subtract their respective speeds to find the relative speed. If they are moving in opposite direction, let's say one is coming from Nairobi, another is going from Nyeri to Nairobi, but they are moving at different speeds, and therefore for us to get the relative speed, we add the two speeds to find the relative speed of bodies moving in opposite directions. Now, how do we use this relative speed that we find? The relative speed, we mainly use it to find the time taken either to overtake a body that is ahead of you if you are going the same direction, or when you're moving different direction, you use it to find the time taken to meet. So when you're finding the time taken to meet, you use the relative speed. And which distance, because we know time is equals to, the time taken is equals to distance over speed. Which speed, in this case, we use the relative speed. Which distance do we use? If you're moving towards same direction, there is this car or body that might have started earlier than the other. So the distance is covered before the other one, the second one starts. That distance is what we use to find the time this car which is coming later that must run for it to overtake the other one. For us to find that time, we use the distance that the earlier car that started earlier has covered before this started. We use that distance and the relative speed to find the time taken to overtake. If you want to find, if they are moving in opposite direction, we want to find the time taken to overtake, we use the relative speed and the distance that is remaining, that is the shared distance. Meaning, if the body started earlier has moved a certain distance, we subtract the whole distance, subtract what has already been covered. The remaining distance is what we use to find the time that must be taken, because that is the time now they compete. If it's at 8, both of them are at 8 at that moment. That is the time the distance that they must compete for them to meet at a specific time or a specific place. So we find the remaining distance, the uncovered distance, to find, and the relative speed to find the time taken to meet. Now, let's do examples for movement in same direction, for bodies moving in the same direction. Example, a van left Nairobi for Kakamega at an average speed of 80 kilometers per hour. After half an hour, a car left Nairobi for Kakamega at a speed of 100 kilometers per hour. So you realize the van left Nairobi at 80 kilometers per hour. Then after half an hour, after 30 minutes, that is, after half an hour, after 30 minutes, a car left Nairobi. They left the same place. So that means we need to find, first of all, the distance the van moved before the car started. Because for us to find the relative speed, of course, if they are moving the same direction, we subtract. So it will be our 100 minus 80. We get 100 minus 80, we get 20 kilometers per hour. That is our relative speed. So for us to find how far from Nairobi did the car overtake the van, first of all, you start with finding the distance the earlier car moved before the second one started. So the earlier car, the distance covered in the van covered in 30 minutes before the car started is, we know distance is speed times time. The speed it was moving at 80 kilometers per hour, and it went for half an hour before the other one started. So it is 80 times 30 over 60, we change to 2 hours. That over 60 times 80, it gives you 40 kilometers. So it had gone 40 kilometers before the car started from Nairobi. So to find the time taken to overtake the matatu, the time taken by the car to overtake the van will be the distance that the the van covered before the car started divided by the relative speed, which gives you 2 hours. So that means for the car to overtake the van, it must run for 2 hours for it to overtake. So remember, after 30 minutes when it has gone, that is the time the car started. And therefore the car must run 2 hours from Nairobi to reach the van. So distance from Nairobi, it must be now the speed of the car, because they are at that time, that is when it is starting, 100, the speed, the distance from Nairobi to the meeting point. It is that distance that the car is going to cover for it to overtake. That's the distance now from Nairobi to overtaking point. So it will be 2 hours, that is the time it's taking to overtake, times its speed, which is 100 kilometers per hour, which gives you 200 kilometers. That is the distance from Nairobi to the point of meeting. Now, if the vehicles are moving in different directions, example, a truck left Nyeri at 7 a.m. for Nairobi at an average speed of 60 kilometers per hour. This is a truck which left Nyeri at 7 at an average speed of 60 kilometers per hour. At 8 a.m., a bus left Nairobi for Nyeri at a speed of 120 kilometers per hour. Remember now the bus is moving faster than the truck, and that's why it started later. Then they might meet somewhere. How far from Nyeri did the vehicle meet? If Nyeri is 160 kilometers from Nairobi, the distance from Nyeri to Nairobi, you are told, is 160 kilometers. Now, the first thing you think of, remember, this one started 1 hour later. So distance covered by the truck in 1 hour before the bus started, it is the 1 hour times the speed, which is 60 kilometers per hour, which gives you 60 kilometers. Remember now the competing distance for them to meet. It is 160 kilometers minus the 60 kilometers that it has moved already, which gives you 100 kilometers. So, and the relative speed, because they are moving in different directions, we add the two respective speeds to get 180 kilometers per hour. So the time taken for the vehicles to meet will be the remaining distance that they must compete over the relative speed, which is 100 over 180, which gives you 5/9 hours. Then, for us now to find the distance from Nyeri, remember from Nyeri, a truck left Nyeri. The truck left Nyeri, it had moved 60 kilometers before the bus started. So, to get the distance from Nyeri, it is already 60 kilometers the truck moved, plus now the time it will take them to meet, it is 5/9 hours times its speed, which is 60. We add the two, we get, this is 33.3 plus this, we get 93.3 kilometers. If you were asked the distance from Nairobi, it could be direct, because you were to find the time the bus will run to reach to meet the truck, which is 5/9 times its speed, which is 120 kilometers, to find the distance from Nairobi to the meeting point. It could be direct. Now let us do some practice questions. Question number 1. The distance between two towns A and B is 460 kilometers. A minibus left town A at 8:45 a.m. and traveled towards B at an average speed of 65 kilometers per hour. A matatu left B at 10:55 a.m. on the same day and traveled towards A at an average speed of 80 kilometers per hour. Remember, this one started at 10:45, and this one which is a matatu, which is moving at a higher speed, started at 10:55. They are moving in different directions, and you are told the distance between the two towns is 460 kilometers. So what we do, we find the distance that the minibus, which left earlier, the distance that the minibus traveled before the matatu started. So a minibus, the difference in hour is 10:55 minus 8:45. You find it is 2 and 1/6 hours. That is 2 hours and 10 minutes. So 2 hours and 10 minutes, we multiply by its speed, which was 65 kilometers per hour. 65 times 2 and 1/6, we find that it had moved 140.83 kilometers before the matatu started. So there is this distance that is shared distance, the distance that they are going to compete. The shared distance, the distance they are going to compete, will be now 460, the whole journey, minus the distances as already covered, which gives you this. And this is the distance we use and the relative speed to find the time they will take to meet. The time taken to meet. So to find the time taken to meet, it is now this distance that is shared divided by the relative speed. And the relative speed, it is 80 plus 65 because they are moving in opposite direction, which is 145 kilometers per hour. So we divide this and this, we find 2 hours and 12 minutes. You can have it in decimal still for multiplication purposes. And therefore, we are asked that how far from B. Remember, from B, it is where the matatu started. So we use the speed of the matatu, which is 80 kilometers per hour, and the time taken to meet, which is 2 hours and 12 minutes. We multiply the two to find the distance from B to where they met, which is 176.09 kilometers. That is 80 times 2.2012 gives you 176.09 kilometers. But key of the question is that at what time did the two vehicles meet? Now they are asking us at what time. Remember, the time taken to meet is 2 hours and 12 minutes. So if both of them started competing at 10:55, we add 2 hours and 12 minutes to find the time they met. So 10:55 plus 2 hours 12 minutes, you find 13:07 hours, which is the same as 1:07 p.m. That is 1:07 p.m. That's the time they met of the day. The of the question is that a motorist started from his home 9:15 a.m. on the same day and traveled to B. So that means a motorist was in the side of A at an average speed of 120 kilometers per hour. He arrived at the same time as the minibus. Calculate the distance from B to his home. So first of all, we need to find the time taken by the minibus to reach the destination. Remember, the total distance is 460 and the speed of the minibus is 65 kilometers per hour. We divide the two, we get 7 hours and 5 minutes. That's the time it will take to reach B. At what time did it arrive B? Remember, it started at 8:45 hours. So if it started at 8:45 hours, we add 7 hours and 5 minutes, we find 15:50 hours or 3:50 p.m. That is the time the minibus arrived at B. So the time motorists must take to arrive at the same hour, it is 15:50 minus the time it started, which is 9:15 a.m., which gives you 6 hours and 35 minutes. So the distance from B to the place of the motorist where it started from, it is the speed of the motorist, which is 120 kilometers per hour times the 6 hours and 35 minutes, which gives you 790 kilometers. 790 kilometers. That is the distance from the motorist's home to town B. The figure below represents a speed time graph for a cheetah which covered 825 meters in 40 seconds. This is how the cheetah ran. It accelerated and it went at constant velocity, then decelerated. Now, we state the speed of the cheetah when the recording of its motion started. The motion of the cheetah started at this point, and the speed at this point was 15 meters per second. We calculate the maximum speed attained by the cheetah. The cheetah started from this point and it started running up to this point. So the maximum speed attained was at this point. So we can let this point to be v meters per second. So if we let this point to be v meters per second, we can find the area of this figure, which we equalize it to the total distance that we are given, 825. Remember, this figure, we can divide it this way. At this point here, we can have a trapezium to this side, and this one remaining here is another trapezium. So we can have two trapeziums. So if you have the first trapezium here, we can have the height as 10. We write this part A and this to be part B. So we can say area here is a half into brackets our 15 plus our B, which is V. So times the height from here to here, which is 10. Then plus this other trapezium, we can say our A is from here to here and our B is here. This our A now becomes 40 minus 10, which is 30. 30 plus from here to here will be 20 minus 10, which is 10. So 30 plus 10 times a half, then times our height now becomes V. V becomes the height. So that is our second trapezium. So we add the two trapeziums, we equalize to 825. So we shall have this one as 75 plus V, because this times this is 5. 5 times this becomes 75 plus 5V. Because we have here 5, you open the bracket with a 5. We have 75 plus 5V plus this one. We can have this is 40, which is 20 times V, it is 20V, gives you 825. We like terms together, this plus this gives you 25. So 25V is equals to 825 minus 75, which gives you 750. So you divide by 25, you'll find V as 30 meters per second. So this is the maximum speed the cheetah attained, 30 meters per second. Calculate the acceleration of the cheetah in the first 10 seconds. Then part 2, the last 20 seconds. In the first 10 seconds up to this, we ask you to find the acceleration. We use the final velocity minus initial velocity over the time taken. The final velocity is 30 that we have found, minus 15 where it started, divided by the time taken, which is 10 seconds. You'll find as 1.5 meters per second square. Meters per second square. Meters per second square is the SI unit for acceleration. Roman 2, the last 20 seconds. The last 20 seconds is from this one is 40 up to here. It gives the last 20 seconds to get the deceleration. So it will be, this is our, it went to 0, remember? It went to 0. So the final velocity becomes 0 minus the initial velocity is at this point, which was 30, minus 30, divided by the 20 seconds. 0 minus 30 divided by 20, which you get as negative 1.5 meters per second square, which was a deceleration at this point. Calculate the average speed of the cheetah in the first 20 seconds. The average speed in the first 20 seconds up to this point. So what we need to know is the total distance from here up to here. The total distance from here up to here. So what we do, we will have to separate this trapezium plus this rectangle. So this trapezium here, which now our but A and B becomes our 30 and 15, we add the 2, then times a half, then times the height now becomes 10. So you multiply, then you add 10 times, because from here to here is to 20 is 10, times from here is 30. 10 times 30 gives you divided by the time taken, 225. This one, when you multiply, you get 225 plus 300, then divided by the time taken, which is 20 seconds, because you are asked the cheetah first 20 seconds, the first 20 seconds. So divided by 20 seconds, you get the average speed for the first 20 seconds to be 26.25 meters per second square. I want to say that we can make mathematics fun, and thank you for watching my videos. God bless you, and remember to subscribe. Thank you.